So let's review systems of linear equations. So in your previous course, algebra, you learned that a system of equations is a set of two or more linear equations, meaning a single variable x and y, that are given together, such as our example on the right. So in a system, each variable represents the same quantity in both equations. That means that x in the first equation is the same exact number that it is in the second equation. It satisfies the conditions of both. To represent this system graphically, okay, you can simply just graph each equation on the axis, meaning if we're thinking of y equals mx plus b format, then you graph your y-intercept and you count from that y-intercept your slope. So in the first equation, the y-intercept is at 0, 0, because there is no y-intercept present. Our slope is 2, so I'm going to place that 2 over 1, and I'm going to come over here and count up 2 and over 1, and you can see that the line is drawn. The same thing happens with the second equation. 5 is the y-intercept, and this slope is negative 3 over 1, so we count down 3 to the right 1, and we create our second line. So now they have this point of intersection, and that point of intersection is the solution to our system, meaning whatever the x and the y coordinate are at the point at which the two cross, their point of intersection, is going to be the x and the y that are equal in both of these equations. So the x in this equation is 1 and the y is 2. So that means when I plug in 1 here and here, I should get 2 for both of my answers. 2 times 1 is 2. Negative 3 times 1 is negative 3 plus positive 5 also gives me 2. So there is the solution graphically. Now, what you learned how to do in algebra were methods non-graphically. So one of those methods happens to be the substitution method. So it's a way to change two equations so you have one equation in terms of one variable equal to that single variable by itself. So here in our two systems of equations, we have x equal to an expression in terms of y. Whenever we have our equations as such, we need to take the expression that my single variable is equal to and plug that expression in to my second equation, like they're doing in our example below. So they're using substitution to rewrite the two equations as one. So instead of 4x minus 3y equals 11, we're going to have 4 times 3y plus 1 minus 3y is equal to 11. And then after you solve, you see that you get y is equal to 1. So now to find the point of intersection, we have our y value, but now we want to figure out what the x value is. So we're going to take this y equal to 1, and we're going to substitute it in to our equation up here. X equals negative 3y plus 1. So we put 1 in place of x and solve, and we end up getting negative 2 out. Now most of us are used to presenting our answer in the form y equals 1 or x equals negative 2. However, if you presented your answer this way or graphically, you are still solving a system of linear equations. As always, our last bullet says to test the solution, substitute your 2 back into each equation to make sure you get out your verified answers.